In this video, we're going to discuss CRA models for the inverse relationship between multiplication and division. So I'm actually starting with, this is the abstract model, and this is a fact family for multiplication and division. So essentially what this is, right, the first two are just we're multiplying 3 and 4 together in any order and getting that same product of 12. So this fact family then is saying if we're starting with 12 and we divide by one of the multipliers, our quotient or our answer will be the other multiplier. Okay. So we'll kind of come back to this, but just wanted to start with that. So for example, we'll look at just a set model just to kind of highlight this inverse relationship. So here this is obviously a concrete model of 3 times 4, so 3 groups of 4. So then when we're looking at this from a multiplication perspective, 3 groups of 4 is equal to 12. We have 12 total. Okay. So we might not necessarily, when we're thinking of these as multiplication models, we're kind of leaving them as the structure, but what we're doing is we're thinking of them as this whole group. I'll leave them spaced out just a little bit so we can still see that grouping. But we're thinking of this as one total group. If we're dividing, right, what we're doing is just the opposite action. Right, so we started, for multiplication, we started with this group structure, and we thought of this as one larger quantity. With division, we're starting with that larger quantity, starting with 12. Let's say we divide it by 3, where 3 is the number of groups. What we would eventually result in is back to that group structure. Right? We would find out that the size of each group is 4 if we're making 3 groups. Okay, so in a set model, it's kind of this idea of thinking of this as groups, and then transitioning to thinking of it as a total quantity with multiplication, or with division, thinking of it as this total quantity first and then dividing that into groups. Okay, so again, it's inverse operation because it's the opposite action that's happening. So that's a set model example. I have length models. I'll just start with one for now. So this is a length model that you could argue is a model for both 3 times 4, right, 3 groups of 4, and really both types of, or both of the division equations in the fact family. Okay, so we could say this also is a model of 12 divided by 3, if we're thinking of this as a length of 12 divided into 3 equal groups, so that's the colors. We could also say this is a model for 12 divided by 4, if we're thinking of it from the measurement division perspective, so a length of 12 divided into a length of 4. Okay, so again, this one's maybe a little bit more difficult to see the opposite action, but we could kind of separate these for division, right? Or kind of start from this perspective for multiplication, right? 3 groups of 4 makes a total length of 12. So that's multiplication. If we have division, let's say we're going to do 12 divided by 4, so 12 divided into groups with the size of 4, we're just doing the opposite action, the inverse action, disconnecting those. So that's one of the length models. The other length model, right, so this is 4 groups of 3. Again, if we said, 12 divided into 4 groups, right, so we have 4 different groups there. Or if we think of this as 12 divided by 3, where 3 represents the size of each group, right, the size of 3, size of 3, size of 3. Okay. So that's a length model. And then for an area model example, these ones actually kind of require the least movement. We can kind of see all 4 of those fact family equations right in this one single model pretty easily. Okay, so 3 times 4, right, we can think of that as 3 rows of 4. We can also see 4 times 3, right, 4 columns with a size of 3. And kind of similarly, we have 12 square units. So if we divide it into rows with a size of 4, right, we can see that we have 3 rows, so 12 divided by 4. Or if we'd say 12 divided into 3 rows, so doing a fair sharing, we can see that the size we drew before. Okay. Okay, so those are all the concrete models. Um, all the representational models would pretty much be kind of the same idea. Those are probably maybe a little bit less common just because that opposite action type of movement is a little bit more cumbersome with representational models, but you can kind of see what those set models, like models and area models, will look like. And then again, this will be kind of that abstract, is kind of this combination of that fact family, just showing that we can multiply those two digits in any order and get the same product, and we can start with that product as our dividend and divide by one multiplier, and our quotient will be the other multiplier.